all at the end. I'm just going to write it and then I will take some examples to explain this. For
Sir,
aldehydes,
all
we
in the
use al
sense
at the end.
butanol,
At the
something like that.
end, yeah, exactly. Butanol, methanol. Are you getting my
Propanol.
point?
Yes, sir. Yes.
Propanol. Okay. Then this is your ketone. So at the end, on we use on, and at the end for carboxylic acid we use oic acid. I will give you some examples. Then it will be more clear. Okay.
Right. Okay, sir.
Can I change the slide?
Sorry for that.
No problem. Can I change the slide?
Yes, sir.
Okay. Now see, always remember when you are going to write the IUPAC nomenclature, you are going to write the name of the branch first. Branch, that means basically substituent. Okay.
Okay.
You are going to name it. When you are going to write the naming, you need to write the all the name of the branches in alphabetical order. Okay. Plus, after this, you are going to write the name of the parent chain. How many carbon present in the parent chain? Then nature of the bond. Nature of the bond, that represents nature of bond. That represents basically whether it is alkane, single bond, alkene, double bond, alkyne, triple bond, if there is any. Okay. Then
Okay.
come to the functional group. Then come to the functional group. Is that clear?
Yes.
Now, whenever functional group is present, this is the main part, the functional group. Everything will be on the basis of this. That means the numbering will be on the basis of this. It doesn't matter where is the other substituent, where is double bond, where is triple bond. If functional group is present, you need to give every preference to that functional group. Is that clear?
Yes, somewhat, sir. Could you explain with an example?
I will just keep it in mind that whenever the functional group is present, this is the superior. You need to do the numbering from where this functional group will get the lowest position. Let's take an example. Let's take an example. If you have this situation, first of all, you need to recognize whether which functional group is present in this compound. So you can see this is your carbon, this is also your carbon, and OH is directly connected to this carbon. That represents it is an alcohol. Yes or no?
Yes. Yes.
So first of all, you need to recognize which functional group is present. And now when you are going to number, you are going to number it. Numbering, you are going to give numbering. So I'm going to start the numbering from here. 1, 2, 3, 4. You cannot do the numbering from left to right. You have to do the numbering from right to left, because functional group is on the right hand side. Are you getting my point?
Yes, sir.
Now, is there any branch that you are looking at? This is your functional group. There is no branch in this compound, right?
No, sir. No.
So when you are going to, when you are done with the numbering correctly, then you start writing the name. Then search for the substituent or branch. There is no branch, then directly jump to the parent chain. So how many carbon in the parent chain is there? 4
So
carbon.
4.
That means but. First you are going to
Yeah.
write but, and then check the nature of the bond. Nature of bond is what? Single. That means alkane. So the name will be butane. Okay.
Nature of bond. Sorry, sir. Okay,
Nature of
butane. Okay.
bond is whether it is single, whether it is double, or whether it is triple. Because
Yes.
for single, double, and triple, we use different name: alkane, alkene, alkyne. Are you getting my point? Since
Yes,
it
sir.
has
Yes.
4 carbon, so it will have butane. Now you are going to write the functional group. Where is the functional group present? At the first carbon. So you are going to write butane 1 all. For alcohol, we use all, or you can directly write butanol when the position is first, because it is understood when you are going to write butanol, that means alcohol is directly connected to the first carbon. Is that clear?
Yes, sir.
Now, if I'm going to give you a very easy question.
Sir, just butanol. Usually there's an E at the end, right? Or
Yeah, when you are going to mix it, the E will be added.
E will be gone. Okay, sir.
Yeah, E will be gone. So can you write the name of this? Can you write the name of this? Always remember that when, you just need to do the numbering correctly and then write the name of the substituent if there is a, then write the parent chain, the nature of bond, then functional group.
Okay, sir.
After this, the chapter is not that much. It will be completed soon. Okay. This part only will take time, some time. Then we will move to the chemical properties, combustion, which is quite easy.
Okay.
Okay. In this week, we can complete this chapter. Then we will
Right.
go with the
Sir,
physics.
could you just tell me how many classes are we gonna take each week?
Okay, so this week we will have 4 classes. I told them to have more classes.
Okay.
So whenever they will arrange we have class on Tuesday, Thursday, Saturday, and this Sunday was an extra class. Okay.
Right.
So I will fix this class. Okay. And yes. So just name it and let me know.
Um, Sir, in the third one which you gave, right? The one on the right side of alcohol or OH, that won't be counted, right?
This part.
No. So that's done. The one below.
Yeah. Where you have which one you are trying? This one or two?
Second, sir.
You should
Second,
go
two.
with you should. Okay. From where you did the numbering?
So from
Left
the
or right?
right side.
Right. 1, 2, 3, 4, 5. Is there any branch? No branch, right? This is the
No, sir.
functional group. No branch. Then directly jump to the parent carbon. How many carbon? 5. So pent
Pen.
and all are singly bonded. Then
Yeah.
pentane. And which position is occupying or taking alcohol? Second. So 2 all. You are not going to write it pentanol. This all this we can mix only when it is on the first position. Are you getting my point?
Yes.
So this
So
is
for the first one is
pentane.
hexanol or
1, 2,
hex.
3, 4, 5, 6 hex, and all are singly bonded hexanol, or one all you can write. Okay.
Yes.
So can I change the slide?
Just a sec. Okay, sir.
Okay. So see, I am going to give you another question. Please do it. Let me know when you are done with this.
Yes, sir. Okay, so done.
Okay, what is the name of the first one?
First one.
Yeah, this one.
Sir, butane to all three in.
First
Is that
one.
correct?
In, what does this represent? What does this in represent?
It's sir. I got it. It's
Nature
a
of
single
bond.
bond. No, what was it?
Okay, see.
In.
You just did the numbering, right? 1, 2, 3, 4. This is your functional group, yes or no?
Yes.
And this is what? This is your branch, right? Of one
Yes.
carbon,
Yes.
isn't it?
Yes,
So
sir.
you are going to write the name of the branch first. So third is the position, and this is your methyl. Meth for one carbon, and when using at a as the branch, we use YL at the end. So it becomes 3-methyl.
Just
Yes
a
or no?
second. Let me.
Okay.
Okay, sir. But in the thing, right? You told while numbering. Okay, we have to take the OH. Okay, sir. Got it. Sorry. Now could you repeat your
Got it.
thing, sir?
3-methyl. Yeah, 3-methyl.
One.
Now we are done with the substituent. There is no other substituent. Then jump to the
Okay.
parent chain. How many carbon in the parent chain? 4
The
carbon.
four.
For 4 carbon, we use bute, right? Bute for 4 carbon. Then jump to the nature of bond. What is the nature of bond? Single, double, triple.
Single. Single, sir.
It is single, so we are going to use butane in at the end that represents single bond. And then jump to the functional group. What is the position of functional group? Second, 2 all.
Okay.
Okay, please do the next.
So just give me a second and I'll do it.
Okay.
So the second one is butane to all.
Butane. Why you are
No,
going for
butane,
butane?
butane.
Not, you cannot write butene. When double bond comes, you need to
Right.
write the position of double bond as well.
Okay. Right.
So
Okay.
you are going
So
to number it
three.
first from where functional group gets the lowest position. You can do the numbering from right side. Yes or
Yes.
no?
Yes. Yes.
Now come to the point. There is no branch. So parent chain,
Right.
you are
Yes.
going to write bute. And at the third position, there is double bond. So 3 in and 2 all. Isn't it easy? You just need to
Yes.
do a little bit uh, practice,
Practice.
and it's very easy. Okay.
Yes, sir.
Now come to this point. You are going to
One.
number it from here 1, 2, 3, 4, 5. Now see, this is a very important question. If you are going to do the numbering from right, the OH, the functional group will get third position. And if you are going to do the numbering from left, the functional group will again gain the first position. Are you getting my point?
Yes.
But if you are going to do it from left hand side, you will be getting bromine first. And if you are going to do it numbering from right hand side, you will getting chlorine first. Are you getting my point?
Yes, sir.
Now you need to decide it on the basis of alphabet. So we will do the numbering from left hand side. See, there will be no effect on OH.
Right.
Okay. But if you need to do the numbering, you just need to do on the left hand from left hand side, because the situation is same. So we will go with the alphabet. So the name will be, we are going to write the name of the branch first, 2-bromo, 4-chloro, then jump to the parent chain, how many carbon, 5 pen, and all are singly bonded, pentane, and then 3 bond. Is that clear?
Yes, sir.
Please do write it. And then we will move to the next alcohol, aldehyde part. For aldehyde, we use al. So if I'm going to directly give you this part, can you name it?
So just to clarify, where so that's Cl plus O, right? Or CH or Cl?
CH. Where is Cl? I didn't write any Cl.
No, sir, I kind of got the wrong idea there. So, sir, where CHO is, right? We can't number that area. Am I correct?
I'm not getting you. Are you saying that we cannot number this?
Yes.
No, we will. What we do count the number of carbon, and there is a carbon, so we will count this number. We will count this carbon. So you are going to count this carbon because we count the number of carbon, right?
Yes.
We don't count any other except carbon. So 1, 2, 3, 4. 4 carbon is there. There is no branch. So its name will be butane.
Yes.
1 al, because there is a functional group. So its name will be butanol. If you are going to see 1, 2, 3, 4, there is a branch of 1 carbon. So what is the name of the branch? 2-methyl butanol. Isn't it easy?
Yes. Yes. Okay, sir.
Please do write the name of this.
Yes.
As well as this. Are you done with this?
Yes, sir.
What is the name of this bond?
Sir,
You did the numbering from here, yes or no? Very good. What is the name of this? See, this C double bond O, and here is carbon and here is carbon. Which functional group is present here? Ketone.
Ketone, yes, sir. So 2-methyl.
2-methyl. How can you say that there is 2-methyl? These are all in. See, I'm going to show you. This is CH3, this is C double bond O, and this is your CH3. And they are all connected in a single line. So it is the parent chain like this. They are all connected in the single line, right?
Yes.
This is the branch. So There is no branch, so its name is prop and all are singly bond. Propane 2 on its name will be. If you can count the number of carbon regularly without any interval or jumping, then it is parent chain. Okay.
Okay, so just a second. So could you repeat it once more?
See, if you can count the number of carbon regularly, then that is parent chain. Like if you are going to count the number, you can see 1, 2, 3. So this is your parent chain, not
Right.
any substituent. But if you are unable to count the number of carbon, like if I'm giving you like this, if I'm giving you like this, you can see you cannot count the number of carbon. This you have to jump it to here to count it in a parent chain. So this is your substituent. Are you getting my point?
Yes, sir.
Can I change the slide?
Yes, sir.
Now see, if I'm going to give you this COOH, what does this means? Which functional group is this?
COOH. Sir,
Carboxylic acid.
carboxylic. Yes.
Yeah, you are going to. Oh, wait a minute. This screen shared has this. Let me know when you are able to see this.
Sir, I can now.
Okay. Now see, it's very easy. You are going to number it 1, 2, 3, 4. 4 carbon is there. So butane, 1 oic acid, or either you can write butanoic acid. Butanoic acid.
Yes.
So can you write the name of this compound as well as this? Please do it.
Okay, so the first one is hexanoic acid.
1, 2, 3, 4, 5, 6. Very good.
And the second one is uh 3 methyl hexanoic acid.
Very good. So you don't have any doubt in this one, right?
No.
You can write the name. Okay. Is that clear?
Yes, sir.
Now moving to the next topic that I already told you, that is homologous series. What is homologous series? See, basically it is a family group, and there are lots of family in organic chemistry. So I'm going to write it is, write with me, it is a series of compounds. It is a series of compounds with similar chemical properties, with similar chemical properties and the same functional group differing from the successive member but by CH2. See, it's very simple. You know, alkane is a family. So they will have a general formula. You know that alkane is a different family from alkene. Alkane has a general formula CnH2n plus 2.
Yes.
And the main point is that if the successive member has CH2 difference, like the first member of alkane is methane, yes or no? The second member of alkane is ethane. The third member of alkane is propane, yes or
Protein.
no? Are you getting my
Yes, sir.
point?
Yes, sir.
Now, if you can see that the difference between this and this successive member, you can see this is CH4 and this is CH2, C2H6. So if you are going to add CH2 in this, won't you get C2H6? You will
Yes, sir.
get it.
Yeah.
So the main point is that homologous series is a series of compounds with the similar chemical properties because they belong to the same family in which the successive member differ with the group that is CH2, or you can say differ with the molecular weight of carbon is 12 and hydrogen is 1 plus 1, that is 14 gram or 14 U.
Okay,
Is
so
that clear?
just a clearance, sir. CH4 plus CH2, won't it be C3H6?
Okay, I'm going to write it here and then add CH4 plus CH2. What it will be? One carbon is here, one carbon is here. They together become C2, not C3,
Oh, okay, so just okay.
right? And four hydrogen here, two hydrogen here, they become C6, C2H6. So these all are basically a homologous series which has a name. Its family has a name, alkane, and they will show similar chemical properties. Their physical properties can be different, but the chemical properties will be same. Is that clear?
Okay. Yes, sir.
In the same way, there is another family that is alkene, and it has a general formula CnH2n. Another family that is alkyne. So if I am going to ask you whether they are from the same family, homologous series of each other or not, just let me know. Just let this is 22 and this is 62. Are they belong to the same family group?
So,
Yes or no?
sir, I'm a bit confused. Could you just elaborate on what you're trying to ask me?
What I want to ask is that are they belong to the same family group? Are they belong to the same family group? That means from which family they are. We have taught you alkane, alkene, alkyne.
Yes, sir.
If both are alkane, that means they belong to the same family. If both are
Yes.
different alkane, alkene, then they are not from the same family. So can you tell me now?
If both are,
Both are alkane, then
yes,
they belong to the same family. If both are
yes, sir.
not alkane,
Right.
so what it is?
So they do not belong to the same family.
How can you say that? Do you have any proof? Can you prove your statement?
But according to the formula, I'm saying that
Okay, according to the formula, number of carbon is 10. What should
10,
be the number of hydrogen? Double
20.
plus 2. So how many number of hydrogen is there? 22. It is an alkane, yes or no? Cethane
Yeah.
H22 is an alkane, yes or no?
Yes.
Now come to this. How many number of carbon is there? 30. What should be the number of hydrogen? Double plus 2. What is the double of 32? 30. That is 60 plus 2, that is 62, right?
Yes.
So they belong to the 30, 30 into 2, that is 60 plus 2, 62. So it is also an alkane.
Yes.
So they belong to the same family group.
So just a clarification, right? Alkene is a different family, or
Alkane is different family, alkyne is different family.
Okay. Okay. So, sir, I
They are
applied the
different.
alkene formula and tried it. That's why I got it wrong. Okay.
Okay, you applied the alkene formula and in both of them, the alkyne formula failed, right?
Yes.
Are you
Yes.
getting my point?
Yes, sir.
Both are failed in for alkyne.
Right.
Okay,
Yes.
and you can see then you should apply another formula because in both they are failed, right?
Yes.
So you should apply alkane then alkyne. Okay, let's say this is your C10H22 and this is your C10H20.
Sir, one's alkanes, one alkyne. Alkene, sorry, not
So
alkane. One's alkene.
so does they belong to the same family group?
No, sir.
Very good. So they are not homologous series as well. If they do not belong to the same family group, they are not homologous. Are you getting my point?
Yes, sir.
Okay. So this is it for what we say homologous series. Wait a minute. Okay. So today I'm going to give you a lot of questions. You need to do that. Okay. So let's start next topic, that is chemical properties. And this chemical property is quite interesting and very easy. Chemical
Sorry, sir, to
properties
interrupt, but my
of
dad is calling me. Can
carbon
I please
compound.
pick up my phone?
Okay, okay, no problem. Yeah,
Thank
yeah.
you, sir.
Mm,
Sorry for that, sir. You can continue.
no problem. So
Right,
I
so you were
was,
telling something about homework. Could you
yeah,
please?
chemical properties of carbon compounds, very easy and very interesting. Okay.
Okay. Okay, sir.
Uh, So we are going to start this chapter topic chemical properties of carbon compounds. That means in chemical properties, what you need to do for what I want to say is that we are studying the chemical properties of carbon compounds. So here
Yes.
we will react these carbon compounds with different things like combustion like O2 and then different water and other things. That is what we call chemical properties. If you are
Okay.
going to study the chemical properties of any compound, that you are going to react that compound with different elements, compounds, or different things, and we will see what is the product. So in this, we have the first, that is combustion. Combustion. Do you know what is combustion? Combustion is basically burning of anything in the presence of oxygen, and burning is not possible without oxygen, right? The fire is
Right.
not possible without oxygen. Burning in
Yes.
presence of oxygen. Presence of oxygen. Okay. So we are going to burn carbon compounds and we will see what we will get. So first of all, I'm going to just take carbon in solid form like coke and all. And you are going to react this with O2. O2, that means combustion. Then you will be getting carbon dioxide plus heat and light. If you are going to
Heat and
react
light, sir. How
heat and
is
light, I'm going to show you. This reaction, combustion, is an exothermic process. This is
okay?
an exothermic process. And in exothermic process, you will get heat evolved. The evolution of heat will
Yes.
be taken. Okay.
Right.
And when you are going to burn something, you will get light also, right?
Yes.
If you are burning something, that then you will be getting light also with heat. The second reaction of combustion is basically, see, this is very important. This is very, you know what is hydrocarbon?
Yes, sir.
Yeah,
Hydrogen
tell
and
me.
carbon.
What is hydrocarbon?
Sir, hydrogen and carbon together.
Hydrogen and carbon. Yeah. Whenever you are going to burn or whenever you are going to react hydrocarbon with oxygen, or you can say whenever you are going to do combustion of hydrocarbon, the product will be fixed. You will be getting carbon dioxide plus water along with heat and light. That represents it is an exothermic process. Are you getting my point? Yes or no?
Not exactly, sir. Could you please repeat?
This
Sorry.
is fixed. This is fixed. See, whenever
What
you are
is
going
fixed,
to
sir? I
burn
think my
any
Wi-Fi is not
hydrocarbon,
working.
no, no,
And your
no, not a
voice.
problem. See, the product is fixed. The product is fixed. What I want to say is that any hydrocarbon that is going to burn, or when
Yes.
you are going to do combustion of any hydrocarbon, you will be getting carbon dioxide plus water.
Okay. Okay.
Okay, you can see
Yes.
this is your methane, this is your methane, and you reacted with the O2, you will be getting carbon dioxide. If you have ethane, or ethene, and if you are going to do combustion or reacting with O2, you will be getting again CO2 plus H2O along with heat and light. Are you getting my point?
Right. Yes, sir.
Now, always remember this, if you are having carbon and hydrogen and others like oxygen, nitrogen, or anything, that is called hydrocarbon derivative. That is called hydrocarbon derivative. Are you getting my point?
Hydrocarbon
Derivative. I'm going to write it here.
derivative.
Okay. First, wait a minute. First, write it. First, write it up to this,
Just this.
and then I'll explain.
Sir, that is CH3, the third one. Hello.
Where it is? CH4 it is.
No, sir.
Yeah. This is your
CH3,
CH2OH. They are together. CH3,
CH3,
CH2OH.
CH2OH.
Its name is
Okay.
ethanol. Two
Ethanol,
carbon.
yes.
Yeah.
Give this. Yes, sir. Done.
Done. Very good.
Yeah.
Now see, what I want to say is that you know that what is hydrocarbon, right?
Yes, sir.
In which hydrogen and carbon is present. Now, if you have hydrogen, carbon, and others like oxygen, nitrogen, and anything, then it is called hydrocarbon derivative. Then it is called
Okay.
hydrocarbon derivative. You don't need to remember this because this term will not be used in your class. And again,
Right.
same. If hydrocarbon derivatives, you are going to burn it, you are going to do the combustion, you will be getting the same product, carbon dioxide plus water plus heat and light. Are you getting my point?
Yes, sir.
So let me show you. This is your, you can see, this is your carbon uh, hydrocarbon derivative. So the product will be CO plus H2 along with light and heat and light, right? Please do right. We don't need to think much more about this alcohol. We need to think about alkane, alkene, alkyne.
Okay, sir.
Let me know when you are done with this.
I'm done, sir. I'm done. I've getting that bit.
Very good. Now see, if you are going to burn alkane, then you will get clear flame. You can easily distinguish between alkane, alkene, alkyne by burning it or doing combustion of that hydrocarbon. So I'm going to write some important point which is very important for this chapter. Write with me. These are very important. There has
Yes.
been question asked regularly. Saturated hydrocarbon, you know that? Just let me know. Can you tell me what is saturated hydrocarbon?
Sir, what is this?
Yeah, what is this?
No, sir.
Yeah, just remember.
Saturated hydrocarbon, the one which has one bond.
Single bond, not
Single
one
bond. Sorry.
single bond
An
between
unsaturated.
carbon-carbon. That is alkane. You can say that. The bond
Yes.
between carbon-carbon single is called saturated and also known as alkane. So if you are going to burn an alkane, it will give you clean flame. It will give you clean flame. Is that clear?
Yes, sir.
Where unsaturated hydrocarbon or carbon compounds will give a yellow flame with lots of black. So if I will give you a saturated and unsaturated, you can burn it. If it will give you yellow flame with lots of black smoke, that means it is unsaturated. And if it gives you clean flame, that means it is saturated hydrocarbon. Okay.
Yes, sir.
And there is another point about this. This results in a sooty deposit on the metal plate. If you are going to burn unsaturated hydrocarbon to cook food, then there will be a sooty deposit on the metal
Sir, what
plate
is
of
sooty
the
deposit?
deposit like okay, there is a layer of black layer. Are you getting my point? Have you seen what we call चूल्हा पे खाना बनाते हुए देखा है कभी
जी,
आपने?
sir.
No.
Yes, sir, I
Yes,
have.
देखा आपने?
जी.
You have, if you have seen, then next time you just when it is cold, then just take it and आप उसे pieces देखिएगा. There will be a layer of the black
Right. Yes.
deposit.
Okay. Okay.
That is what I'm calling. Okay.
Sooty deposit. Okay.
Okay. There is another important point. This will give you a clean flame. Only oxygen is enough. If the oxygen is enough, supply of oxygen is enough. If the supply of oxygen is not enough, then there will be also deposition in saturated hydrocarbon as well. So we can write limiting the supply of air leads to incomplete combustion. Incomplete combustion. Of even saturated hydrocarbons giving sooty flame. So please write it.
Sooty flame or sooty deposit?
Limiting the sooty flame. It will be if there will be sooty flame, then there will be sooty deposit.
Okay. So sooty flame will be the one which causes sooty deposit.
Yes.
Done with.
Then okay. Now the next is basically oxidation. Oxidation, and it is very important. What is oxidation? So see, oh wait a minute. Here we have alcohols are converted to carboxylic acid. Carboxylic acid. Or you can say alcohol is oxidized to carboxylic acid. Carboxylic acid. If you remember, can you tell me what is oxidation?
Sir, where one so what do we substance or carbon? One substance gets
No.
oxidized and the other gets reduced.
No, I just asked you only the half part. What is oxidation?
Sir, when one substance is oxidized.
What is oxidized?
Sorry, sir.
What is oxidized? You
When
just
a
said,
substance gains oxygen during a reaction.
yeah, this is what I wanted to hear.
Okay.
Addition of oxygen or gain of oxygen, that is called oxidation. Removal of hydrogen or loss of hydrogen, that is called reduction. Okay.
Removal of hydrogen or oxygen.
Also called oxidation. See, I'm going to write it here. Gain of oxygen, either gain of oxygen or
loss of
loss
hydrogen.
of
That is
hydrogen. Loss of hydrogen. This is called oxidation, right?
oxidized.
And what
Yes.
is reduction? What is reduction?
So
Gain
that's
of
called
hydrogen.
oxidized, right? Not oxidation.
No, basically oxidized we can use like this substance is oxidized.
Okay.
And we can
okay,
say like oxidation of this substance occurs. Okay, that depends. Okay.
Right.
So it's all the sentence. Gain of hydrogen or loss of oxygen, that is called reduction, right?
Yes.
Now see, we have, can you name this compound? CH3, CH2, OH. What is the name of this compound?
So just a second.
Left hand side. Yeah.
Okay. So,
Which functional group is present first? You need to.
that's alcohol, right?
Yeah. How many carbon in the parent chain? Is there any branch or anything?
No, sir. 2 carbons.
2 carbon. What is the name for 2 carbon?
Yes. Ethanol.
Both are saying ethanol. So see, Hassaan, if you have an alcohol and you are going to use alkaline KMnO4, alkaline that means basic KMnO4, potassium permanganate, or acidified K2Cr2O7, that means potassium dichromate, and if you are going to heat it, then this ethanol will be directly converted into carboxylic acid. Then this ethanol will be directly converted into carboxylic acid. Now, as you can see, what you need to do, you just need to remember this reaction. This reaction is very important. However, you are going to remember, you just need to remember, you know that this is ethanol, and you can easily write the formula of a carboxylic acid having 2 carbon, because you know that carboxylic acid is this, yes or no? This can be written as this. This is carboxylic acid, and you need to add 1 more carbon, and this carbon will be satisfied by hydrogen. So what you will be getting? You will be getting this formula, right?
Yes,
and
sir.
how the oxidation took place, you can see there were 3 hydrogen. There were 3 hydrogen between this and this, right? Total hydrogen you can count 6 hydrogen were there, right? And in this
Yes, sir.
you can see
Just
only
could you go back to 6, sir? 6 there.
okay, yeah, you can see how many hydrogen is there? 6 hydrogen total.
Yes, sir.
In
Okay, hydrogen.
ethanol, 6 hydrogen is there, and
Yes,
how
sir.
many hydrogen in this? 4 hydrogen only left. That means loss of hydrogen is called oxidation. Oxidation took place or not?
Yes.
If someone is losing hydrogen, that means oxidation of that substance that someone is taken place, right?
Yes.
or you can also take see it in with respect to oxygen. There are only one oxygen. Now there is two oxygen in this compound. Okay,
Okay.
please do write it. This reaction is very important. You need to, and this is basically this. This is reagent which is oxidizing agent. Their work is to do oxidize.
Yes, sir.
Please do let me know so that I will write a point about it. Then we will. Done.
Yes, sir. Let's take this one.
Okay, just write.
So could you just go up for a second? Sorry, just for the.
Yes, yes, no problem.
Okay.
Is it enough or should I?
Yes, so that's completely fine.
Oh, just let me know when you're done.
Okay, so yes, please continue.
Thank you. Now see, alkaline potassium. Alkaline, that means basic. You know what is basic, right? Alkaline potassium permanganate. Or acidified potassium dichromate, or acidified potassium dichromate are oxidizing agent. They will oxidizing agent, are oxidizing alcohols. They are oxidizing agents. That's why they are oxidizing alcohols to acids. That is adding oxygen or addition of oxygen